Example 2.1 is all about creating a library of parent functions. And essentially what a parent function is it will be a basic shape that we can create in the Cartesian coordinate plane. And what's going to govern that is going to be different equations. So there's different operations that we can do to numbers, and that will create various shapes or parent functions that we're going to use to study pretty much the rest of the course. So the first one that I have here, it says the equation is y equals 3. It just says y equals 3. So the idea here behind this particular equation is that every time you pick a real number, you will always map it to 3. So let me show you what the function definition would look like. We would say, let's call this one f. Say f, and you can take any real number that you want, and you can do this. And this will be given by the equation f of x equals 3. So I replace where it says y with the name of the function in function notation. That's where the f of x comes from. And from a table perspective, we will have x for the first column, f of x for the second column, and we will select values from the real numbers to play with. And if we pick enough of them, then we can start to see a pattern emerge in the Cartesian coordinate plane. Now, like I said, this particular equation says no matter what number you pick, you will always map it to 3. So -2 maps to 3, -1 to 3, 0 to 3, 1 to 3, and 2 to 3. So from a numerical standpoint, there's certainly a pattern. Everything maps to 3. From a graphical standpoint, let's see what happens with this. Start putting all these points on here, and the pattern should become pretty clear. We end up with a nice horizontal line. Now, when we start defining these functions, we typically try to define them with the largest possible domain. That's exactly what I've done right here. That is your largest possible domain. So we'll take that and we'll extend the pattern to not just the values that we've chosen, but to all conceivable real number values. So the pattern would then produce this horizontal line. And this particular type of function is known as a constant function. And it gets its name because the value that you see in the second column is always constant. It's the same value, it never changes. And the shape of this is a horizontal line.